Hi, so what we're going to be doing in this video is differentiating inverse trig functions. Okay, so the derivative of the inverse sine function is 1 over the square root of 1 minus x squared. Okay, and I've been very particular about putting this in brackets because it's whatever is in here is all squared, which we'll come to in a bit and hopefully makes sense. Derivative of the inverse cos function is negative 1 over the square root of 1 minus x squared. And lastly, the derivative of the inverse tan function is 1 over 1 plus x squared. Okay? So again, these are given in your formula sheet, which you'll have on the exam. So it's good to remember them, but ultimately you've got a formula sheet, so that's something you can always refer back to. It may become a bit more tricky when we have to do later on in the course when we're doing integration, and it's recognizing these, but we'll come to that when we get there. Okay, so I'll show you a few examples. Find the derivative of the following: y equals sine to the negative 1 of x cubed. Now, we can't forget any of our previous rules we've learnt, so differentiate, check our formula sheet. It's 1 over the square root of 1 minus what's inside the brackets there, x cubed squared. And that's what I meant there, is we need to be really careful with that, so it's going to square whatever that is. And then always remember, chain rule times the derivative of what's inside the brackets, which in this case is x cubed. What's the derivative of x cubed? It's 3x squared, so our final answer is just 3x squared over 1 minus x cubed squared is x to the power 6. Okay. Next one, I want to differentiate cos to the negative 1, or the inverse cos of tan 3x. So derivative of cos, inverse cos I mean, is 1 over square root of 1 minus tan 3x all squared times the derivative of tan 3x. So what's the derivative of tan 3x? You would check your formula sheet if you can't remember them, which I can't. You can't see this right now, but out of sight of the camera there is a board with the derivative of tan x written, so I can refer back to that. Don't know why. I could have pretended that I knew them, but I don't. I would always check myself. And my board is out of sight. Tells me that the derivative of tan x is sec squared x, so it's going to be sec squared 3x, and then think chain rule again, times the derivative of 3x. So our final answer is going to be, the derivative of that is 3, so we're going to get negative 3 sec squared 3x all over the derivative, square root 1 minus tan squared 3x. Okay, so to be really careful about this. So the derivative of the 3, so 3 times the negative times the sec squared x, so that's why they all come up on the top, and then that's our answer. Okay, so I'm going to slightly more complicated one because, again, like I said, we can't just forget all of our previous rules of differentiation. I'm now differentiating 2x cubed times the derivative of sine to the negative 1x, and so this is going to be using the product rule. So remember that is times the first, differentiate the first, leave the second, add, leave the first, differentiate the second. So differentiate 2x cubed, and we get 6x squared, and then we leave the sign to the negative 1x, all adding 2x cubed times the derivative of sine to the negative 1x, which we can check, will give us 1 over square root of 1 minus x squared. So we can simplify that, 6x squared sine to the negative 1x plus 2x cubed all over square root of 1 minus x squared. And that is us differentiated that. So again, we can't just forget anything we learned in the past, so this is going to be using stuff that we learned in higher. However, it's using differentiation techniques derived from advanced higher. So calculate the coordinates of the stationary point on the curve y equals tan to the negative 1 e of x over x. So it's essentially, I mean, you could be asked to calculate the coordinates of a stationary point in higher, but now we're doing the same thing but with advanced higher techniques. So first thing we need to work out is how you calculate the coordinates of a stationary point. So the stationary point is when dy by dx equals 0, because that's when the gradient equals 0 at the stationary point. So we need to differentiate. And derivative of tan to the negative 1 of x is 1 over 1 plus e to the x over x, all squared, times by derivative of e to the x over x. Okay? Sorry, didn't mean to bump that. And so then let's differentiate this. And again, that's going to be using quotient rule. So we've got 1 over 1 plus e to the x over x squared, so it becomes e to the 2x over x squared, because it firstly becomes e to the x squared, and e to the x squared becomes just e to the 2x, times by derivative. So quotient rule, differentiate the first, leave the second, subtract, leave the first, differentiate the second, all over x squared. So we're going to end up with e to the x dot x minus e to the x all over 1 plus e to the 2x over x squared times x squared. Okay. Now I could break this out and calculate that and then work out what the most simple form is, but ultimately because the question is saying calculate the coordinates of the stationary point, straight away you can just say make that equal to 0, because that's how we're calculating the coordinates of the stationary point, which means all of this is going to cancel out because we bring it up and it'll be multiplied by 0. So really we're actually just doing e to the x dot x minus e to the x equals 0. How are we going to solve that? We can take out a common factor of e to the x, leaving x minus 1 equals 0, which tells us that e to the x equals 0 and x minus 1 equals 0. So that means e to the power of what gives 0. So x would equal 1. Anything to the power of 1. So that doesn't have a solution because there's nothing. So yeah, no solution. Okay. So we know that x equals 1. I didn't ask for just the x coordinate. I asked for the y coordinates as well. So we know that y equals tan to the negative 1 of e to the 1 over 1, because I've now substituted that value in here. Tan to the negative 1 of e. And we get our calculator. Oh no. Whew. Shift tan e, which is, number e is alpha, there, 69.8. So our coordinates are 169.8. That's derivatives of trig, inverse trig functions. Mixing up my words. Right.